All right, IBAASL2. We've reached well, sort of not the end, but we've reached a pausing moment in integration where we're going to have an assessment. There's going to be 2 targets on that assessment. I know it seems like we've moved rather quickly to get to 2 targets, but you will have multiple opportunities on these targets. It's just that these 2 targets pretty much go hand in hand when you're building an assessment. So the first one is going to be integration concepts. This is very similar to our target in first semester of like derivative concepts or basic derivatives. So these are like the basics of integration. Know that when you're integrating, you're finding an antiderivative. You're working backwards to find an original function that someone took the derivative of. The notation is the stretched out s, and then dx is that variable of integration that you're taking it with respect to. I showed you guys how to do the reverse power rule. Reverse power rule is like the 1 over n plus 1 times x to the power of n plus 1. Just helps you get back. It's like the opposite of the power rule. Remember, anytime you integrate something or anti-differentiate something, there's so many different ways to say it, there needs to be a plus c on the end. That's that constant of integration. We also learned how to do composite functions. Remember, composite means that there's like an inside function. So we'll put a little note about that there's an inside function. It's a backwards chain rule, essentially. So when the inside equation is linear, it's not too bad because you just have to blast the outside of your integration with a 1 over a being the coefficient on the x inside the linear function. But if the inside function is anything for nonlinear, you need to use u substitution. So you call the inside function u, you take the derivative u, you put everything in terms of u, you do a little algebra magic, you integrate it, and then you replace the u with whatever you started with in the beginning. The second target we're doing is called applications of calculus. There's really only 2 or 3 different things that we can test you on in terms this round of testing for applications of calculus. We might expect you to find a specific c value. So not just leaving the c value there, but actually finding what the c value is. Usually the only way you can do this is by if they give you a coordinate that lives on the original function, that you can plug it in to the antiderivative that you found to solve for c. Then once you have that original equation, we might ask you to find specific values. So if we give you like an x value, you can plug it in and maybe do a little interpretation if it's like some sort of word problem. I guess in general, applications sort of means that it might involve a word problem. Speaking of word problems, kinematics. They're not gone, they're back. Remember that the OG function is the displacement function, then the derivative of that is velocity, and the derivative of that is acceleration. We're still doing the same kinematics we've always done, but now you guys are able to move not just downward on this little ladder here. You're not just going down from displacement to velocity to acceleration, but now that you can integrate, you can also go up any of these. Like if I gave you velocity, you could move up to find displacement using an antiderivative. Okay, I think that's all I have for you guys. Good luck with the review.